Welcome back, dear students. Let's continue with question number 15. So question 15 says, the shaded region in the following diagram represents the lawn in the form of a house. On the three sides of the lawn, there are flower beds having uniform width of 2 meter. Okay, so if you look at the diagram, this shaded part represents the lawn. Okay, so it represents the lawn. Now on the three sides, you see there are three sides. So on the three sides we have flower beds. Okay, so we have got flower beds. So this represents flower beds having uniform width 2 meter. It means that from here to here this width is 2 meter, this width is also 2 meter, and this width is also 2 meter. Now find the length and breadth of the lawn. So that's what you are asked to find. So you have to find what is the length and breadth of the this shaded part. Now see here carefully. So from here to here is 30, means from here to here is also 30. Okay, and how much is this? This is 2, and this is also 2. So from 30 we will subtract 2, and we will subtract this also, that is this 2 as well. Okay, so that's why your length will be 30 minus 2 minus 2, which is 26 meter. So I got the length, that is this much. Okay, now question is asking you to find what? Question is asking you to find the breadth also. So breadth means you have to find this much. Now from here to here is 12, and from here to here is again 2, isn't it? So from 12, and that is from here to here, it is 12. So from 12, if you subtract 2, you will get the breadth of this particular lawn. Okay, so that's why your breadth is going to be 12 minus 2, which is going to be 10. So I got my first part answer. Okay, now the second part of the question says, hence or otherwise find the area of the flower beds. So you need to find the area of this white part. Okay, now how to calculate area? See, you can do this thing. So from here to here, see, this entire thing can be considered to be one rectangle. Okay, so kindly look at where am I showing you. So this can be acting like one rectangle. Now this part is also one rectangle, and this part is also one rectangle. Okay, now this rectangle and this rectangle, they are exactly the same rectangle. Okay, because its width is 2 meter, and from here to here this height is all of 10. So length becomes 10 and its width is 2. So for this also length is 10 and width is 2. Now for this rectangle length is 30 and width is 2. So that's why area of the flower bed can be calculated as, so this is length into breadth, that's 10 into 2, this is also 10 into 2. Okay, and this is 30 into 2. Okay, so when you add all of them, you get your area of the flower bed to be 100 square meter, right? So you may pause the video and note down your solution. Let's move to the next question, question number 16, which says, a floor that measures 15 meter into 8 meter is to be laid with tiles measuring 50 centimeter into 25 centimeter. Find the number of tiles required. So first and foremost, let's see how to find number of tiles. Okay, so what you need to do here is, first we'll find what is the area of the floor. Okay, so on the floor of dimension 15 into 8, you have to lay some tiles whose dimension is this much. So what we need to do is, we will find area of the floor and we will find area of the tiles with the same unit. Remember, unit has to be same. So area of the floor will be 15 into 8, which is 120. And since the unit given here is meter, so that's why your area's unit will be square meter in this case. Okay, now area of one tile, see, it is given in centimeter. So what we will do is, we will convert this into meter. So 50 centimeter, when you convert this into meter, you get 0.50, and when you convert 25 into meter, then you get 0.25. so multiply these two, you get 0.2125 square meter. Therefore, number of tiles required, we calculate number of tiles using this particular formula. Area of the floor is 120, right? And area of one tile is given to be 0.125. Now when you simplify this, your answer turns out to be 960. That means you need 960 tiles to cover the entire floor. Okay, now if a carpet is laid down on the floor so that 1 meter so that a space of 1 meter exists between its edges and the edges of the floor, what fraction of the floor is uncovered? See, understand the situation. Suppose this is your floor. Suppose that this is your floor. Now what you are doing is you're keeping one space. Okay, so you are keeping a space of 1 meter all around. Okay, so you want to cover this much part with the tiles. So that means question is asking what fraction of floor is uncovered. Okay, so that means you have to find the fraction of this pink part. Okay, so let's see how to find this. Now what is the area of the carpet uncovered? Okay, so if I ask you what will be the area of this, it will be easy. Okay, it will be very easy. So kindly find it. Find the area of this part. Remember the dimension. Dimension is from here to is 15 and from here to here is 8. Remember, and the width is given to you 1 meter all along. Okay, so if you find the area, it turns out to be exactly. All right, so what you can do is this is one rectangle and there's one more similar rectangle, that is this one. Okay, whose length is going to be 15 meter and width is going to be 1 meter. So its area is going to be 15 into 1. Okay, so that's what is written out here. And from here to here, okay, so this entire thing is given to be 8. So remove this one, so you get 6, right? So for this rectangle, this will be 6 into 1. This is 6 and this is 1. So 6 into 1, and since you have got one more of similar kind, so that's why you are multiplying with 2. So you get 42 square centimeter to be the area of the space which is uncovered with tiles. Okay, right? So that's why fraction of floor uncovered. So see this much part out of 120. See this entire area is 120. So from 120, 42 is uncovered, isn't it? So do the cancellation, you get your answer to be 7 by 20, right? So pause the video and note down your solution. Let's move to next question. So question says two adjacent sides of a parallelogram are 28 centimeter and 26 centimeter. If one of the diagonal is 30 centimeter long, find the area of the parallelogram. Also find the distance between its shorter sides. So there is a parallelogram. You see, this is the parallelogram, okay, whose adjacent sides are 28 centimeter and 26 centimeter. So you can take this longer side to be 20 and 28, and you can take this to be 26. Okay, now one of the diagonal is 30 centimeter long, so you can consider this blue colored diagonal, and this length is given to be 30 centimeter. Question is asking you to find the area of the parallelogram. Now one thing that I want to say here is, if this 28, this is also going to be 28. If this 26, this is also going to be 26. Okay, so basically if you observe here, this diagonal divides this parallelogram into two triangles. One is this triangle and another is this triangle. Okay, so in order to find the area of the parallelogram, what I can do here is I'll find area of this triangle, I'll find area of this triangle. In fact, both the triangles are congruent, because see, this is 26, this is also 26, this is 28, this is also 28, and this side is common. So using AAA criterion, I can say that these two triangles are congruent. So it's enough that if you find area of one triangle, area of another triangle will also be the same. Okay, so find area of one triangle and multiply it by 2, you'll get area of the parallelogram. Okay, so that's why what we have is we have to calculate the area of a triangle having sides 28, 26 and 30 centimeter. So three sides are given, so use Heron's formula. So calculate S turns out to be 42. So area of the triangle using Heron's formula will turn out to be, so I'm not showing you the all the calculations, but you have to show, okay, in exams you have to show. So when you simplify this, you get 336 centimeters square. So area of one triangle is 336 centimeters square. So that's why area of the parallelogram will be 2 into area of the triangle, as I said earlier. So 2 into 336 will give you 672 centimeters square. So this is the area of the parallelogram, right? Now question is asking you, second part of the question is asking you to find the distance between its shorter sides. So this is these, see this one and this one, they are shorter sides, isn't it? So you have to find the distance between them. Now all of you know area of a parallelogram. One of the formula for calculating area of the parallelogram is height into base. Okay, so if you consider this as base, then the distance between the shorter sides acts like height. You have to keep that in mind. Okay, so keep this shorter side, that is 26 centimeter, as your base. Okay, and since we don't know height, okay, we'll keep it as it is. Area of the parallelogram is 672. So bring this 26 to the denominator. So you get height equals to 672 by 26. So when you calculate that, you get your answer to be 25.84 centimeter. Okay, so I got the distance between the shorter side, which is 25.84 centimeter. You may pause the video and note down your solution. Let's move to question number 20. So question number 20 says, the perimeter of a rhombus is 52 centimeter. If one diagonal is 24 centimeter, find the length of, okay, so what are the things that are given? So let me quickly write it. So ABCD is a rhombus, okay, and its perimeter is given to be 52 centimeter. Okay, now I'm taking each length. Okay, all of you know that in the rhombus each side will be equal to each other, so I'm taking each side, measurement of each side to be A. Okay, then the perimeter is given to be 52, and perimeter is going to be how much? Actually it will be A plus A plus A plus A, that is 4A, isn't it? So perimeter will be 4A, so 4A is given to be 52. So from here calculate A. So A turns out to be 13. So that means each side of this rhombus measures 13 centimeter. Okay, so we now question is asking you to find, see, one of the diagonal is 24 centimeter. You have to find length of other diagonal. Okay, so it is given that AC is 24 centimeter, isn't it? Now what am I going to do is I'll just join them. Okay, now see, what you can do here is, or one of the very important property that you need to remember is, the diagonals in the rhombus bisect each other perpendicularly. That means here if I call this point, okay, so we have to find, all of you know, BD. So if you observe this, okay, so if you observe any triangle out here, so for example, if I observe this triangle, this will be the half of AC, as I told you. Okay, so AC will get bisected because of BD. So this acts like, this much is AC by 2, isn't it? Okay, and this much acts like BD by 2. Okay, so this diagonal will also get bisected, so this will be BD by 2. This is the AC by 2, this is BD by 2. Now as I said, this is going to be 90 degree. Okay, they will get bisected perpendicularly. So if this is 90 degree, then side opposite to this, that is AB, acts like your hypotenuse. And all of you know AB is nothing but A, isn't it? Small a, right? So that's why, as per Pythagoras theorem, you know, hypotenuse square is equals to perpendicular square. You can call this perpendicular, and you can call this as base. Perpendicular square plus base square. Okay, now all of you know A is 13, right? So 13 square. AC is 24, so 24 by 2 is 12, so 12 square plus BD by 2, we'll keep it as it is. Okay, so from here, so 13 square is 169, 12 square is 144. So when you get it here, 169 minus 144 gives you 25. So BD by 2 whole square turns out to be 25. So from here, if you calculate BD turns out to be exactly 10. First find the square root. So you get BD by 2 equals to 5. So BD will be equals to 2 into 5, which is 10 centimeter. Okay, so I got BD, isn't it? So I got the BD. So that's why the other diagonal will be 10 centimeter. Now question is asking you to find its area. Now all of you know area of rhombus will be half into product of the diagonals. I've given you the formula. So half into product of the diagonals. So we have diagonal AC is 24, BD is 10. So when you calculate this, it turns out to be 120 square centimeter. Right, so you may pause the video and note down your solution. Okay, so let's move to the last question for the day, question 22, which says, the figure given below shows the cross section of a concrete structure. So this is the cross section of a concrete structure. Calculate the area of the cross section. So basically you have to find what is the area of this closed figure if AB all this measurements are given. Now before I do this, I'm going to draw this line and I'll call this point as point H. Similarly from C I'll draw a perpendicular and I'll call this point as K. Okay, now you see there are two rectangles. One is this rectangle, one is this rectangle, and this is one triangle. Okay, so I'll find the area of this rectangle, I'll find area of this rectangle, and I'll find area of this triangle and add all of these areas, so you'll get area of the cross section. Okay, right. So given is AF is equals to 1.2, EF equals to 0.3, and DC is equals to 0.6. All these things are given. Now what will be BK? Okay, so BK will be, see here carefully, see here very carefully, AF. Okay, so AF is this one. So AF is given to you 1.2 meter. Okay, EF, that is this is given to be 0.3, DC is given to be 0.6. Okay, now BK, what will be BK? And let's see what are the other stuffs given to us. Okay, AB is given, right? So from here to here is given to be 1.8. Okay, and what is given to us? We are given, see here, from here to here is 1.8, isn't it? Now my question is, from here to here is how much? From here to here. So from here to here will be, see, from here to here is, see, if this is EF, which is 0.3, then this is also 0.3. Okay, and since DC is given to be 0.6, this is also going to be 0.6. So from AB, if you remove this much, that is 0.3, and if you remove this much, that is 0.6, then you get BK, isn't it? So that's why BK is 1.8, that is AB minus AH minus HK, that is 1.8 minus 0.6 minus 0.3. So when you calculate this, this will be equals to 0.9. So that means BK, this is how much? 0.9. Now question is asking you to find the area, right? So area of this figure A, B, C, D, E, F will be equals to area of, see here, AHEF plus area of HK CD plus area of triangle KBC. Okay, now area of triangle rectangle AHEF. Now what is the length? AF is the length, which is 1.2, and breadth is given, breadth that is EF is given to be 0.3. So that's why this becomes 1.2 into 0.3. Okay, plus we have this triangle, this rectangle. Now all of you know this is 0.6, isn't it? And how much is this? See here carefully, this is given to be 1.2, and how much is DE? DE is given to be 0.8. So 1.2 plus 0.8 is 2, isn't it? So this length becomes 2, and breadth is how much? Breadth is 0.6. So that's why you have 2 into 0.6 plus, now all of you know this is 2, and this is your perpendicular, and this is your base, right? Base is 0.9. So area of triangle KBC will be half into base into height. So half into base. Base is 0.9 into height. Height is 2. Okay, so you just need to do the cancellation. This and this gets cancelled. You multiply all these, and when you simplify this, you get your answer to be 2.46 square meter. So this will be the area of this whole cross section. Okay, so with this we close for the day. You may pause the video and note down your solution. Thank you very much.